Okay, so in this class we are going to discuss some iterative methods, how to solve system of linear equation. So what will be our idea? So we will be restrict our view to only 3 cross 3 matrix. Basically, we will be considering 3 equation with 3 unknowns. The method can be extended to any number of unknowns. Okay. So suppose this is the equation. This is the system of equations. A11. Okay. A11 x1 plus A12 x2 plus A13 x3 equals to, let's say, B1. This is first equation. A21 x1 plus A22 x2 plus A23 x3 equals to B3. And here last equation is A31 x1 plus A32 x2 plus A33 x3 equals to B3. So we have three equations with three unknowns, and you assume that the system has unique solution. Okay. Then how to obtain that solution using some iterative approach. So what is the approach here? What are the unknowns here? Or let me remove them. Let me make them x, y, z. Otherwise, because in the unknowns I will be applying subscripts, so it will be a bit difficult to remember or understand. So let me write down x, y, z, x, y, z, x, y, z. So here unknowns are x, y, and z. So what we'll do, we'll start with some initial guess. X equals to x naught, y equals to y naught, and z equals to z naught. Now we do not know. We can take any value. We can take any value of x naught, y naught, z naught. There is no restriction on them. Okay, if nothing is known to you, if you are not getting any better approximation, you can simply take x equals to x naught equals to 0, y equals to y naught equals to 0, and z equals to z naught, which is 0. So you can take 0, 0, 0 as initial solution. Then what you do, you keep on improving the solution. So if it is initial stage, then after first iteration, the value will be x1, y1, z1. Then the values will be x2, y2, z2, and so on. So in this way, you will be keep on improving the solutions. Now when to stop? So in this way, you will reach xn, yn, zn. So these are the solutions vector. Huh? And in this way, you are improving the solutions. Now when to stop? What is the stopping criteria? So stopping criteria will be, so you can decide. So it will be as soon as the difference between two consecutive iteration is less than certain fixed number. So you have decided that epsilon is very small quantity. You have decided certain epsilon may be 0.001 or maybe 0.002 or maybe 0.0005, anything you can decide. Now when to stop the iteration? You will be stopping the iteration when x n minus xn plus 1 minus xn, that will be less than epsilon, yn plus 1 minus yn, that will be less than epsilon. Zn plus 1 minus Zn will be less than epsilon. So all these three quantity together, they all have to be less than, they all has to be less than epsilon. If that is happening for certain n, then you will be stopping at n plus 1 iteration. Now how to formulate the iterative scheme? So I am telling you that you will be keep on improving. So how to improve? So to improve the solution, you have to create certain iterative scheme. So let's see how we can create that scheme and what are the necessary and sufficient condition for the convergence of that iterative scheme. So first iterative scheme will be due to Gauss and Jordan. So first method is, which I am going to discuss, Gauss-Jordan method. Just a moment. Gauss-Jordan method. So what we are going to do? So we will assume that the diagonal elements in the coefficient matrix are all non-zero. Diagonal entries, ये जो diagonal entries आप दिख रहे हैं, ये these are the diagonal entries A11, A22, A33. Suppose they are all non-zero. अगर कोई एक diagonal entry जीरो हो जाते हैं तो क्या करेंगे non-zero करने के लिए? System of equation को क्या करेंगे? What will be the order of the equation? That will be changed. For example, if this is the system of equation, 4x1 plus x2 plus x3 equals to, let's say, 10. Then x1 plus some here is 0 plus, let's say, 7x3 equals to 9, and let me add another equation, 4x1 plus 9x2 equals to 4. So here you will not be able to apply that scheme directly. You will know why. So first let us see how to create the iterative scheme in Gauss-Jordan method. So what you do, you assume that AII is not equals to 0. I am creating the scheme for that arbitrary three equation with three unknowns. So assume AII, the diagonal entries of the coefficient matrix are all non-zero. If the diagonal entries of coefficient matrix is 0, then what you have to do? You have to rearrange the order of the equation in such a way that in the new form, after changing the order of the equations, all the diagonal entries in the modified coefficient matrix are non-zero. You have to do it, and it is possible. If the system has a unique solution, then it is possible. It is always possible to rearrange the equation. Now, if the dimension is large, then that may be difficult to do, but you are only changing the order of the equation, so you can do it. So assume AII is not equals to 0. Then what you do? So I'll be naming the equation 1A, 1B, second equation, and third equation 1C. So solve for x from first equation, solve for y from the second equation, and solve for z from the third equation. Tell me what is x. Then system capital A can be written as, then system A can be written as, what will be x? What will be x? 1 by A11 into B minus A12 Y plus, not plus, it will be minus A13 Z. So that is X. What will be Y? Solve for Y from the second equation. 1 by A22, it was B1. So it will be B2 minus B2 minus B2 minus A21X minus A23Z, and solve for Z from the third equation. So that will be 1 by Z equals to, so Z equals to 1 by A33 B3 minus A31X minus A32Y. Okay, so this will be the values of X, Y, Z. Now from this I am going to create the iterative method. Left hand side on X, Y, Z you put the subscript n plus 1, and on the right hand side for Y and Z put the subscript n. So what you are getting? Tell me. So X n plus 1, I am putting superscript. No harm is there. This is just a notation to denote the value at the n plus 1 at the iteration. So xn plus 1 is equals to 1 by a11 b1 minus a12 yn minus a13 zn. Yn plus 1 is 1 by a22 b2 minus a21 xn minus a23 zn. And what is zn plus 1? 1 by a33 b3 minus a31 xn minus a32 yn. So, and what will be n? N is 0, 1, 2, 3 and so on. So this is the scheme. It is known as Gauss-Jordan method to find out the solution of a system of equation. Now, first thing, the first question which is coming, does this method always converge? Does this scheme which you have created always converge? The answer is no. The answer is no. Sufficient condition for the convergence of Gauss-Jordan method is, so if you write down in matrix form, so if you write down this system in matrix form, so that will be capital X power n plus 1 equals to some matrix H into x power n plus some constant matrix C. How? What is xn plus 1? Can you tell me here? What is xn plus 1 here? What is capital Xn plus 1 here? If you write down the above scheme in matrix form, what it will be? Can you tell me? What is x power n plus 1? So n plus 1 is column vector. That will be small xn plus 1, small yn plus 1, small zn plus 1. What is h? What is h? H will be minus. So let us start with first. So h will be 0, 0 minus a12 by a11 minus a12 by a11 minus a13 by a11. That is first row. Second row will be my uh, A21 minus by A22 0, then it will be minus A23 by A22, and what will be the third row? Minus A31 by A33 minus A32 by A33 0 into x n y n z n, and what will be the constant? C, this is column vector. So C will be B1 by A11, B2 by A22, and B3 by A33. So you see, I have written the Gauss-Jordan scheme. I have written the Gauss-Jordan scheme. This is Gauss-Jordan scheme or Gauss-Jordan method. So I have written the Gauss-Jordan method in matrix form. X power n plus 1 equals to h into x power n plus c. I should not say power n plus 1. Value of x in n plus 1th iteration is equals to h into value of x in nth iteration plus c. So sufficient condition for convergence of, so let me write down, you should know. So necessary, so as I told you, when this method will converge, what is the criteria on the coefficients? It is not always converge. It is not like you will be creating x, y, z arbitrary thing and you will be using this scheme and you will get the solution. No, you have to create the scheme in such a way that the iterative matrix has to satisfy certain condition. So this matrix H, which I have written here, basically the same thing here. This matrix is called iteration matrix. Iteration matrix, and this matrix A11, A12, and let me write down. So from the system, if you write down the coefficient, what is the coefficient matrix from the given system? A11, A12, A13, A21, A22, A23, A31, A32, A33. That will be coefficient matrix. You know it. The name of the matrix, coefficient matrix. So here I am going to state the necessary and sufficient condition for the convergence of the Gauss-Jordan method. Now proof is beyond the scope. Proof is a bit difficult and bit lengthy, so I will not be including. I'll only be stating the result. So the necessary and sufficient condition for the convergence of Gauss-Jordan method is Gauss-Jordan method is the iteration matrix has to be is row of H. Row of H is spectral radius of the iteration matrix. Spectral radius of the iteration matrix. Iteration matrix has to be less than 1. Has to be less than 1. Row of H has to be less than 1. Row of H has to be less than 1. What is row of H? Spectral radius of the iteration matrix, not coefficient matrix. Iteration matrix. So what is spectral radius? Absolute value of the largest eigenvector. Absolute value of the largest eigenvector. So spectral radius is absolute value of the absolute value of the largest eigenvalue. Absolute value of largest eigenvalue. Eigenvalue. So you know what is eigenvalue, eigenvector. So जो largest eigenvalue होंगे अगर so that will be the spectral radius of the iteration matrix. and वो एक से छोटा होना चाहिए. अगर होते हैं so that will be the necessary and sufficient condition. ना हम लोग तो इटरेशन मैट्रिक्स को क्रिएट करके उसके बाद उसको आइगन वैल्यू बना के चेक करना थोड़ा डिफिकल्ट होगा. So we have another criteria. If that is satisfied, then rho of h will be automatically less than 1. Okay. So rho of h has to be less than 1. That is the necessary and sufficient condition. But it will be a bit difficult to check this. First you have to create the iteration matrix. Then you have to find out the largest eigenvalue. It has to be less than 1. So there is another way, but that will be only sufficient condition. So sufficient condition, if that is satisfied, then spectral radius will be automatically less than 1. So another condition we have sufficient condition, that is only sufficient. Sufficient condition for the convergence of Gauss-Jordan method is that the matrix, the coefficient matrix has to be diagonally dominant. Now it is coefficient matrix, not iteration matrix. That the coefficient matrix has to be diagonally dominant. Diagonally dominant. What is the meaning of diagonally dominant? What is the meaning of diagonally dominant? Diagonally dominant का मतलब है कि absolute value of the diagonal element should be greater than or equals to sum of the absolute sum of the remaining element in that row. अगर if you take absolute value of the diagonal element in any row should be greater than equals to absolute sum of the remaining elements in that row. Okay, so if that is happening for all the rows, then that coefficient matrix is called diagonally dominant. So in mathematical form it should be AII, that should be greater than equals to summation I equals to 1 to n I j equals to 1 to n, j not equals to I aij for all I equals to 1 2 up to n. How many rows are there? So mod AII, that is what? Absolute value of the diagonal element in any row that is greater than equals to absolute sum of the remaining elements in that row. It has to be true for all the rows. If that is happening, then the matrix is diagonally dominant. And if the matrix is diagonally dominant, then the spectral radius of the iteration matrix is always less than 1. It will be automatically less than 1. Okay. So that is why we can check using this diagonally dominant concept. So let me write down few matrix and you tell me whether that is diagonally dominant or not. What about this matrix? 4 1 1 3 5 1 0 5 9. What is that? Is it diagonally dominant? Is it diagonally dominant?
Yes, sir.
It is diagonally dominant because diagonal elements So in each row, 4 is greater than 1 plus 1, 5 is greater than 3 plus 1, and 9 is greater than 0 plus 5. So this is diagonally dominant matrix. What about this? This is diagonally dominant. Dominant. What about this one? 1, 5, 0, 3, 7, 2, 1, 1, 8. What about this matrix? Is it diagonally dominant?
Yes, sir.
How? How it is diagonally dominant? The second one. What is A11? A11 should be greater than the sum of the other elements in that row. So what is A11? 1. 1 cannot be greater than equals to 5 plus 0. क्या होना है? A11 should be greater than equals to A12 plus A13. A22 should be greater than equals to A21 plus A23, and A33 should be greater than equals to A31 plus A32, which is not happening for the given matrix. Is it happening? A11 is 1. It is not greater than equals to 5 plus 0. It is not greater than. So it is not happening for all the diagonal elements. So it is not diagonally dominant. Okay. So you know what is diagonally dominant. So if the matrix is diagonally dominant, you can certainly apply Gauss-Jordan scheme. Now can you tell me, here you see in this system, how shall we write down the Gauss-Jordan scheme? How shall we write? So what we are doing basically, we are solving for x1 from the first equation, x2 from the second equation, and x3 from the third equation. Then we are creating the scheme. But here we cannot apply. Can we apply? Because x2 coefficient is 0. So we cannot solve for x2 from the second equation. We cannot solve for x3 from the third equation. So what shall we do? To apply Gauss-Jordan scheme, गॉस-जॉर्डन स्कीम अप्लाई करने के लिए ai should not be 0. तो क्या करेंगे हम लोग, इक्वेशन की ऑर्डर चेंज कर देंगे. सो दिस कैन बी रिटन एज 4x1 plus x2 plus x3 equals to 10. Next equation will be 4x1 plus 9x2 equals to 4, and third equation will be x1 plus 7x3 equals to 9. Now we can solve for x1 from the first equation, solve for x2 from the second equation, and solve for x3 from the third equation. And we see that while doing so, the coefficient matrix is diagonally dominant. What is the coefficient matrix now? Here, coefficient matrix will be 4, 1, 1, 4, 9, 0, 1, 0, 7. So this is diagonally dominant coefficient matrix. So if we apply Gauss-Jordan method, whatever initial guess we choose, after that will be leading towards the solution of the given system of equation. Okay, so that was the theory. So let us quickly solve one problem and see what shall we do. So here what I will be going to do, I will be showing you the proof from the PDF. That calculation is a simple addition and multiplication. So let me show you from the PDF. Just a moment. I have to stop sharing my screen. Okay. Open with. Do you see my screen now? Students, do you see my screen?
Yes, sir, it's visible.
Okay. So you see here from this PDF, this is a part of the book from B.S. Grewal. Ah, so here, if you look at the system, 4x1 plus x2 plus x3 equals to 2, x1 plus 5x2 plus 2x3 equals to minus 6, x1 plus 2x2 plus 3x3 equals to minus 4. So what is the coefficient matrix now? You remember that was sufficient condition. Even though sometimes the coefficient matrix is not diagonally dominant, the iteration scheme may convert, but you should give care to make the coefficient matrix diagonally dominant if it is possible. While doing so, convergence will be guaranteed. So here, what is the coefficient matrix? 4, 1, 1, 1, 5, 2, 1, 2, 3. This is the coefficient matrix. Is it diagonally dominant?
Yes,
Is
sir.
it diagonally dominant? Is the diagonal entries greater than equals to sum of the remaining elements in that row? 4 is greater than equals to 1 plus 1. Next diagonal entry is 5. So 5 is greater than equals to 2 plus 1. 3. Next diagonal entry, 3 is greater than equals to 2 plus 1. So the coefficient matrix is diagonally dominant. So you can directly solve for x1 from the first equation, x2 from the second equation, and x3 from the third equation, and you create the Gauss-Jordan iterative scheme. So which has been done here? Which has been done here? So these are the schemes. These are the. Is it okay? So shall I write it for you? How do we get the scheme, or do you follow it from the book? You tell me. I'll be creating the scheme. Tell me what will be x1. X1 will be 1 by 4, 2 minus x2 minus x3. X2 from the second equation will be 1 by 5 minus 6 minus x1 minus 2x3. Then x3 will be 1 by 3 minus 4 minus x1 minus 2x2. So this is the solution of x1, x2, x3 from first, second, and third equation. Now you have to create the scheme. So left hand side superscript will be n plus 1, n plus 1, n plus 1, value of x1, x2, x3 at n plus 1th iteration, and left hand side this is n. Now you start with any initial guess, because since the coefficient matrix was diagonally dominant, whatever initial guess you take, it will be converging to the solution of the system. So what are the solutions? Can you tell me what are the exact solution of this system? Later you verify it. Now what you do? You may start with any initial guess. So here in the book, first you have to choose the initial guess as 0, and then another time choose another initial guess and see what is happening if you consider few iterations. What are the values, updated values? So when you will be choosing x1, x2, x3 all 0, then after fifth iteration you are getting the values x1 at 50 iteration is 0.93778, x2 at 50 iteration minus 1.07422, and x3 at 50 iteration minus 1.09998. So these are the approximate values after fifth iteration. What are the exact solution? Exact solution of the given system is 1, -1 and -1. So you see this is very close to 1, this is very close to -1, this is very close to -1. Now I know there is a difference. So if you want your answer to be more accurate, you have to perform more number of iteration. Okay, you will be keep on applying the iteration until you get the solution with desired accuracy. If another initial guess is considered, then also you will be getting the solution. It will be a little bit different, but in that case, after 50 iteration, the solutions are 0.96889 minus 1.03712 and minus 1.04999. So they are close to -1, this is close to -1, this is close to 1. So you are getting the solution using Gauss-Jordan method. So the sufficient condition is the matrix, coefficient matrix has to be diagonally dominant. Now, one disadvantage of this method is that we have already updated value. You see, while calculating x2, here you see, while calculating y, we have already updated value of xn plus 1. xn plus तो 1 तो हम लोग पहले इक्वेशन में ही कंसीडर कर लिए. yn plus 1 जब कंसीडर कर रहे हैं तो उसमें x की वैल्यू यूज हो रहा है, लेकिन गॉस-जॉर्डन स्कीम में पुराना जो प्रीवियस इटरेशन में x की वैल्यू था वही यूज हो रहे हैं. बट यू कैन यूज हियर द न्यू अपडेटेड वैल्यू ऑफ xn plus 1. So if you do so, then the scheme will be Gauss-Seidel scheme. So as soon as you have some updated value, use them in the iteration scheme. And if you do so, you will be getting Gauss-Seidel iteration scheme. So let me write down that. Next is Gauss-Seidel. Okay. So Gauss-Seidel will be very similar to Gauss-Jordan. Only improvement will be as soon as you have some improved or updated values, use them in the iteration scheme. Now what will be the benefit of that? The benefit of that will be if Gauss-Jordan and Gauss-Seidel both converges, then Gauss-Seidel will be converging at least 2 times faster. Okay? अगर दोनों ही मेथड में सोल्यूशन आपको मिल रहे हैं तो गॉस-जॉर्डन में आपको स्लोअर सॉल्यूशन मिलेगा, गॉस-साइडल में आपको 2 टाइम फास्टर सॉल्यूशन मिलेंगे. मतलब यही कहना चाहता हूं कि गॉस-जॉर्डन में आपको अगर 10 इटरेशन की जरूरत है तो गॉस-साइडल में 5 इटरेशन में आपको सॉल्यूशन मिल जाएगा विद सेम एक्यूरेसी. अगर गॉस-जॉर्डन में 100 इटरेशन की जरूरत होते हैं तो गॉस-साइडल में 50 इटरेशन में आपको सेम एक्यूरेसी में सॉल्यूशन मिल जाएगा. So that is the benefit of Gauss-Seidel. So what is the scheme here? As soon as you have some updated value, use that in the iteration scheme. So for the same system, so Gauss-Jordan में क्या होंगे, कहाँ improve होंगे बताइए. This was Gauss-Jordan scheme. इसको अगर Gauss-Seidel बनाने हैं तो क्या क्या करने होंगे बताइए. xn plus 1 फर्स्ट इक्वेशन में कोई चेंज आएंगे क्या? फर्स्ट इक्वेशन ये देखो जो yn zn और xn ये जो दीज आर द वैल्यूज ऑफ x y z इन nth इटरेशन. ओके, तो xn plus 1 की कैलकुलेशन में किसकी वैल्यू यूज हो रहे हैं? yn और zn की. तो उसको पुराना वैल्यू ही लेना पड़ेगा. yn plus 1 y की nth plus 1 वैल्यू में कौन सी वैल्यू यूज हो रहे हैं? x in nth iteration and z in nth iteration, but we now have value of x in n plus 1th iteration, so we can improve this value of n. We can replace this value by n plus 1. zn plus 1 की वैल्यू में कौन सी वैल्यू यूज हो रहे हैं? x in nth iteration and y in nth iteration. But by this time we already have improved value of x and y. So here also we can improve this xn and yn. Okay. So Gauss-Seidel scheme will be xn plus 1 equals to 1 by a11 b1 minus a21 yn minus a31 a13 12 ये आपको इक्वेशन से मिलेंगे 1 2 1 3 it will be zn. What will be yn plus 1? Yn plus 1 will be 1 by a22 b2 minus what? b2 minus क्या था उसमें देखो a21 and a23 a21 and a23 a21 x power n plus 1 minus a23 z power n, value of z in nth iteration and value of x in n plus 1th iteration, because you have updated value of x now. What will be z n plus 1? Value of z in n plus 1th iteration, it will be 1 by a33 b3 minus a31 value of x in n plus 1th iteration minus a32 value of y in n plus 1th iteration. Okay, so this is the Gauss-Seidel scheme. Gauss-Seidel scheme. All other convergence criteria are same. Gauss-Seidel scheme will be convergent if the iteration matrix, all the eigenvalues of the iteration matrix are less than 1. If that is happening, then the spectral radius of the iteration matrix will be less than 1. So then that will be the necessary and sufficient condition for the convergence of Gauss-Seidel method. Now spectral radius find करना iteration matrix के थोड़ा difficult होंगे. So another criteria will be if the coefficient matrix is diagonally dominant, that will be sufficient for the convergence of Gauss-Seidel method. Okay. So if you look at the PDF here, you will see the difference. Gauss-Seidel iteration scheme. You see, as soon as updated values are available, use them in your scheme. So this is the only difference. बाकी sufficient condition जो मैंने डिस्कस किए थे वो सारे सेम है. So you see, can we apply to solve this system? Can we apply Gauss-Seidel method to solve this system directly without doing anything? Yes, because the coefficient matrix right now, if I write, that will be diagonally dominant. 45 will be greater than 2 plus 3, 22 will be greater than 3 plus 2, and 20 will be greater than 5 plus 1. So the right now the coefficient matrix is already in diagonally dominant form. So from this we can solve for x1 from the first equation, x2 from the second equation, and x3 from the third equation, and then you create the Gauss-Seidel scheme. Okay. Now Gauss-Seidel scheme. So we have considered this system of equation. Now if the matrix is diagonally dominant, आप कोई भी initial guess choose कीजिए, that will be leading to the exact solution of the given system. So here we are choosing x1 and x2 and x3, all these values to be 0 at the initial stage, and then you keep on improving them according to the Gauss-Seidel scheme. And you see, after fourth iteration, the values are 1.000, 1.99999, and 3.00000. So what are the exact solution? Exact solutions are 1, 2 and 3. So it is, see, you already have obtained. Only after fourth iteration of Gauss-Seidel method, you have obtained the solution. Okay, so that is why Gauss-Seidel method is very powerful. Only after fourth iteration, you have obtained the solution of the given system of equation. Few other examples are there. You go through it. I will upload this part of the book. So that was Gauss-Seidel and Gauss-Jacobi method. Okay, you go through this. Anything you want to ask? Students, anything you want to ask? Okay.
No, sir.
Okay, fine. So these two are iterative scheme to solve system of linear equation. In most of the time, if the dimension of the systems are less, then these one of these two methods are used. You can use Gauss-Seidel method to obtain the system of solution. Okay, so remaining topic in this unit is how to find out largest eigenvalue. As I told you, eigenvalue, eigenvectors are very important in application. Here in numerical analysis also you see eigenvalues are used. It's a eigenvalue of the iteration matrix. All of them has to be less than 1. So how to find out the largest eigenvalue? Okay. So there is not a technique. There are some techniques to find out the largest or smallest eigenvalue and corresponding eigenvectors. So that thing will be discussed in the next theory class. Power method. How to find out the largest eigenvalue and its corresponding eigenvector for a given matrix. Any given matrix. What will be the largest eigenvalue and what will be its corresponding eigenvector. Now, what matrix multiplication does? If you consider a 3 cross 3 matrix and if you multiply a vector in 3 dimension by that matrix, you will get another vector. So what basically happens in 3 dimension, if you multiply a vector by a matrix of order 3 cross 3, vector will be either rotated or it will be stressed or both will be happening. It will be rotated and stressed. So eigenvector will be that vector which is invariant under matrix multiplication. मैट्रिक्स मल्टीप्लिकेशन करने के बाद भी वेक्टर अपना डायरेक्शन चेंज नहीं करते हैं, उसी डायरेक्शन में रहेंगे, बस उसकी लेंथ छोटी या बड़ी हो जाएंगे या सेम रहेंगे. तो जो फैक्टर से वो छोटी या बड़ी या सेम रह रहे हैं, दैट फैक्टर इज कॉल्ड द आइगन वैल्यू. एंड जो वेक्टर डायरेक्शन चेंज नहीं कर रहे हैं उसको कहते हैं आइगन वेक्टर. तो वो डिस्कस करेंगे एंड देन विल बी discussing the method how to find out the largest eigenvalue and its corresponding eigenvector. Okay, so I'll stop the discussion at this point. आप लोगों को अगर कोई कुछ पूछना है तो पूछिए. I'll try my best to answer them. Any questions? Okay.